Hi, I'll be going over the umpire process for linked list cycle. So given head, the head of a linked list, determine if the linked list has a cycle in it. There's a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. Internally, pos is used to denote the index of the node that tail's next pointer is connected to. Note that pos is not passed as a parameter. Return true if there is a cycle in the linked list, otherwise return false. So we have the first example, 3, 2, 0, -4. That -4 looks like it connects back to 2. So we're getting a linked list, 3, 2, 0, -4, and then pos equals 1, and we return true because there is a cycle. Then we're given another linked list, 1 and 2, and 2 connects back to 1. So head equals 1, 2, and pos equals 0, so return true. And then in the third example, 1, head equals 1, pos equals -1, we return false because there is no cycle. So one way that we could do this problem, actually I didn't do match, so in terms of matching, I do think I have seen a similar problem before, so I don't know if I've seen this exact problem, but I have seen something similar, I believe. And then from that problem, I remember we used like a set, like a scene set, and then we just we had to iterate through the loop, and yeah, so it was mostly just like adding those nodes to the scene set and checking if it's in the set or not. So I'm gonna use that approach since I have that like in my memory. So I'm going to first create that scene set. So scene equals set. And then, of course, we need the current pointer. So current equals head, right? So we have a pointer to iterate through the linked list. And then, so while current, so we just want to check if our current node is in the set first. So if current in scene, that means we have a cycle, so we return true. Otherwise, we just want to add the current node to our set. So I think scene.add means add current, and then we'll add the whole node instead of just the value. So we use the addresses of the node, and we can actually see if we have really visited this node before or not. So yeah, because I think you might want to use current.value, but actually using the current node, the node object is the best way to go about this if you're going to go with this solution. And then so we just add a current node object, and then if we reach the end of the list, then it means that we don't have a cycle, and we just return output true, but it should be false. So return false. So yeah, we just have the set current equals the head, and while current, if current is in scene, we return true because that means we've cycled, but we're always adding the current node object. Then if we reach the end of the linked list, we just return false because that means we have a regular linked list and we don't have a cycle. Okay, so I'll go ahead and run it. This should be working. Let's see. Oh darn, so I didn't get the right answer here. So scene equals set, current equals head. Oh, I forgot to update the current pointer. So current goes current.next. So that's pretty important. Let's see, this should be working now. Let's see. Okay, nice. So yeah, we got all the 3 test cases, and I'll go ahead and submit it. Okay, nice. So yeah, it looks like this solution is working. And then in terms of evaluating, because we're using the set, and then um, we might not have a cycle, right? So in our worst case, this could be O of n for space. So our set could be as long as our linked list. And then for space, it's the same idea, I believe. So we're iterating through the linked list, and then if we don't have a cycle, then we might go through the whole linked list. So that could be O of n in that situation. So for space and time, looks like my solution would be O of n for both. Okay, and then thank you. That's my Umpire process for linked list cycle.